Okay, everybody, welcome. If I'm correct, then you can hear me. Maybe confirm that on the chat if you like, so I know that that I'm visible and you can hear me and loud and clear. Great, thanks, Sander. So we have a webinar today for, let's say, 40 minutes to an hour. I think it's one of the most interesting topics that we have, and I can guarantee you that we have way more to discuss than the time frame that we have. So the discussion is on AI, and in particular from a strategy, geopolitical, and market angle, right? So we're not going to code together. This is more high over. We'll look into what AI means for society and where things are going together. If you have questions, which I'm pretty sure you will have, please put them on the chat, put them in the Q&A box. I'm here with Kent. Kent is our head of growth at Chemo, and we will together sort through the questions and answer them when they come. And of course, at some point after the lecture, we will try to answer them. So with that said, let's dive in. I'll share my screen. And we have a couple of slides prepared for you to get going. Here we go. So let's start with the, oh, 1 second. I'm in the wrong slide. Let's start with the goal of today, right? So what do we hope you'll get out of the next hour? Yeah, here we go. Something very simple. The next hour should be to take you from a Hollywood idea of what AI is to a more grounded, realistic idea of what is AI and what can it do for me, right? So take it away from fiction and be more grounded in where this is actually going. Of course, I think you recognize a lot of the movies here on the screen, whether it's Black Mirror, the series, or it's Her, the movie with Joaquin Phoenix, or it's Westworld. The common theme is that it doesn't end well for humanity, right? That is how AI is portrayed in the movies. What we're going to do is something way more simple. We're going to look at the market, who's paying for this, why are they paying for this, what's the underlying technology, a bit of hardware, a bit of software, and what's going on between countries here, right? Because as you may know, there's a rivalry going on between, for example, China and the US, but maybe also some other players. So main goal, bring you from Hollywood to reality and give you a better understanding from a couple of different angles into the technology. Let's start with something simple. I want to get to know you a bit and understand how much you know about this space. So question to you, how much do you know about AI, 1 to 10? And I'll give you the poll right now. So I think you should see it on your screen. How much do you know about AI already, 1 to 10? And please be honest, right? So I'll try to tailor my story a bit to the answers that you're giving me. Okay, see quite some answers already in. That's great. And I think the story here is 5 more seconds. Okay, so the highest score with 10 votes out of 43, I think, is 4. So let's conclude that we know a bit about AI, right? So quite some people said 2, 3, or 4, or 5. So that's the peak, and then we have lower numbers on the side. So you can see the results here. I have one more question before we go in, and it might sound like a weird question, but it's quite an important one, I realized. How much do you fear AI? So how much are you afraid of everything that's coming in this space? Same question, again, 1 to 10. Last poll that I have for you today, but how much are you afraid of this technology? And maybe again, on the side, you could do a correlation between the two questions, right? See if people who are more knowledgeable have more or less fears. Would be an interesting one to figure out. Okay, I think most people have voted. And I think quite an interesting data set. We have quite a group, let's say 30% of us saying 1, 2, or 3. So very low fear. We have a couple of people in the middle saying 5 or 6, but we also have a couple of people at the other end. So it's not uniform, but it's quite spread between let's say 1 and 10. So we have lots of different fear levels in this group. So I'll try to attend to all of those, and my guess is that the fear will go down a bit if you see what's coming next. Okay, starting with what is AI, right? Simple answer. The purpose of AI is try to automate or potentially surpass human cognition, right? So cognition is is our rational thinking, how we problem solve as human beings. The difficulty is, of course, like, what is the real goal? Are we trying to mimic human beings? Are we trying to make something that is as smart as a human being? Or are we trying to build something that's smarter than human beings? And I think most AI enthusiasts will say it's the latter, right? We're trying to build something that's at least in specific areas better than human beings. And those specific niches or areas could be like skin cancer detection, right? So it's a very narrow use case, but if it's not better than human beings, why would you build it in the first place? So in many cases, it's a spiky, niche case specific, aim to surpass human level cognition. Of course, there are lots of sub-dimensions in cognition, and for the psychologists in this group, I'm a psychologist by training, by the way, some areas we already are better than human beings, right? Memory in your computer is technically in many ways better than human memory, which is quite fallible. Language, GPT-3 and those kind of models, we're getting closer. Vision, computer vision, we're getting closer, right? So for some of those, we are getting there or have already surpassed human level cognition. For others, consciousness, emotions, goal-driven behavior, and movement, if you follow those robotic movement competitions, you can see that we're still quite far behind human capabilities. Maybe a good start is to look at the market. So what is this whole AI hype and where is the money going? The super interesting perspective, because it will tell you a lot about what it actually is and what it isn't. So this is the slide that I like the most. It's a McKinsey slide. It's a couple of years old, but it's still one of the better ones if you want to understand this particular market. So what does it say? I know it looks complex, but it has a very simple message. In the next 10 years, AI as a general purpose technology will add between 13 and 15 trillion US dollars to global GDP, right? So what does that mean? Well, it means that it's a very sizable chunk. So 15 trillion, the global economy right now is roughly 90 trillion. So it's very sizable. It's a very big thing. It's cross industry. So it's not only in healthcare or only in real estate or only in retail, right? This is a cross industry thing. So the technology, which is in many cases building predictive models, is useful for a lot of different sectors, right? And that's why it's so interesting. It's not limited to one particular country or one particular sector. And what are the big chunks? You can see it a bit here in the chart. So the bigger the square, the bigger the chunk of predicted value. And my takeaway is that there are two main chunks. One is really at the front end. It's where you capture user attention, where you try to engage users. So it's sales, it's marketing, it's optimizing engagement in applications, in software, right? So that whole user front end logic is very big. At the same time, really in the deep down the funnel, if you can say, like or in software you call it back end, but in manufacturing, in actually making products, making things. That's another very big chunk, right? So predictive maintenance in a factory where you can predict when certain elements in the chain are going to break and then repair them in time so you don't have any downtime. So it's those kind of very big use cases, but there are many others, from customer service to lead generation to churn reduction, you name it. But the big two things that at least I take from this chart is really the end user understanding, modeling people, understanding behavior, making things more engaging, and then predictive maintenance. But all in all, across industry, cross country, and that's why this whole space is so interesting. Of course, it might be really valuable. Doesn't mean that everybody gets the same share of the pie, right? So, and I think there's a lot of fears for, especially within countries, on how this will play out. So, what are the forecasts for specific nations? And I think here the forecast that I can find is that China is set to get a lot of value from this because they're moving really fast. They also have different legal systems which allow more data pooling than, for example, in the EU. And there's a lot of government funding going to this space. Then it's the US, but of course also a very nice ecosystem. And then it's the other countries that will profit from this. Why is that the case? Lots of reasons, right? If countries decide to jump in, really prioritize this, having an AI strategy, having the funds ready to commit to this, that matters a lot. The ecosystem, for example, venture capitalists that can support, matters a lot. And you see the same thing on industry level. Not all sectors or industries have the same ability to profit from this, the biggest one is manufacturing, as already discussed, right? So this whole optimization of yields from your chain, I think, and then predictive maintenance kind of elements, that's a very big chunk, where for other areas, it's less important. Of course, in technology that's so hot, there is a lot of funding. So this funding is increasing. The data is a bit outdated, but let's say it increases 40% per year, year on year, right? So that's a lot, meaning that the investment streams in AI-led initiatives are increasing rapidly. And I think given the use cases already shown, that makes a lot of sense. There's something here, if you look a little bit deeper, because I can just tell you, hey, it's growing at 40%, fair enough. But the more interesting chart, I think, and this chart is a little bit confusing, but what I aim to show here is that this kind of growth, where something is growing at like 50% year on year or 60% year on year, is really outrageous, right? It's not how other industries grow. So if you look, for example, at milling machines or at piston engines, so physical hardware, and you look at the improvement rates for that hardware, then typically you're modeling something with 2% improvement year on year, right? Or your engine in the car might get more efficient by 5% year on year, right? So those are quite normal rates. So yes, it's improving, and it's improving exponentially. There's a factor of 1.05 every year. But for AI, it's quite different, right? So, and there's in particular, all the intelligent software tools, the rate is way higher. So for language models, the speed of improvement in the last year is closer to 100% growth rate, right? So that's a very different model than modeling something that's growing by 2%. So the message here is it's growing really rapidly, much faster than a lot of other industries. So therefore, it might come across as quite surprising. And under the hood, you will find that it's actually not, it looks linear. It feels like it's linear, but actually it's a jump from S-curve to S-curve, right? So it's every time you need a new invention to get to that next level. Like transformer models were a big invention in the last few years, right? And GPUs and these kind of things. So every time you need something that brings you to the next level, it's not a linear path. It's actually a jump from S-curve to S-curve. But all in all, these things grow way faster than traditional industries, and that makes it a really interesting and exciting space to work in. Of course, AI doesn't grow alone, right? So it grows together with a lot of other things, and those are interconnected. So the whole sort of start of cloud computing to be really, really effective and efficient and easy to reach people. So for us as an AI startup, it was super easy to get access to cloud companies. Actually, we had many that were competing for our services, which give you really good deals if you start, right? So the first maybe 50K or 100K in cloud credits you will get for free. So it's those kind of things that you have access to the compute, the pricing is reasonable, the amount of data that you can get from partners or from users or from anybody that you need data from, the number of devices that are in the market, so connected devices that are able to generate data, they all add to this whole thing that is AI, right? So of course it relies on data, it needs compute, and it needs devices that are able to generate data for you. So in terms of what is the market, what is it, if you're an investor, what is this really about? At the moment, if you say AI, you actually mean software, right? In many cases, it's a software market. So you sell intelligent software. Is it the same as normal software in terms of margins? Not entirely. AI is a little bit less profitable so far. So gross margins in software, if you model that in an Excel sheet for an investment round, you would typically use 80% or so as a gross margin, where in AI, it's a little bit lower. But more or less, it's the same, and it's the software market. And of course, that's not only the case, because you have now hardware markets that are popping up with specialized silicon, with GPUs, with TPUs, with sort of processors that can handle parallel computation. And that market is now growing. But let's say for now, it's still largely a software market. And it's an interesting software market because it's a place where a lot of people share code. 50% of the papers on Archive, for example, have their code published on GitHub, so you can actually see everything under the hood. And a lot of people have packages that they share that are open source. Take a PyTorch or a Pandas or TensorFlow, any of those packages that you can install very quickly. Also, these things matter a lot because they increase the speed of how quickly people innovate in this space, because they're using the same tools. Those tools are very modular, very scalable, and code quite often is accessible as well. Another thing, and this is more intuition, so don't look at the accuracy of the chart, but it's about the intuition here. So when do we create value in the AI space? My answer is you create value if you build something that's better than human cognition and you can scale it, right? So, and that is a bit of an S-curve situation. So let's say you build a system to predict skin cancer. And you can see that picture here on the lower right corner. This is someone's back, right? And you have all these little spots that might potentially be skin cancer. So the task here is a classification task, right? Is it skin cancer or is it something, something more benign? And that classification task you can train with AI models, especially if you have samples that are pre-labeled. So you have samples of skin cancer and samples of benign skin, how do you call those things? Yeah, I don't know what the name is for it, but little dots on your skin, right? So the moment where your AI system becomes better than the regular doctor, and you can scale it to all the doctors, so you have the infrastructure and the network to scale it, that's the moment where your AI model becomes valuable, right? And then, of course, you can scale it rapidly to everybody else. So, but this is the thing, like for a long time, you will not hear about it because it doesn't matter. It's worse than human beings. And then at some point, suddenly it surpasses human beings and it's a big thing. Another thing that is that's important here is how quickly do we as end users adapt to this, right? Because we may have an AI system that can predict whether you should be hired or not, or it can predict whether you have skin cancer or not, or anything in those things. But still, we need to have wide-scale adoption to make that work, right? So how quickly does the doctor adapt and start using that thing? How quickly does the company adapt and start using that thing? And in practice, this is quite strongly dependent on lots of other things like regulations being in place or not, or national policies where they either force you to start adopting this or they don't. And in that case, you might survive for a long time without using this technology. But all in all, and I think the chart here is pretty clear, all in all, in the past, if you build a new technology, right, that first thing is the radio, I think. It would take a very long time before adoption hits plus 80%, right? Between 1900 and 1950, so it took almost 50 years to get that to most of the households. But now if you build something like we're trying to do with Chemo, right? You're trying to have your app on all the phones in the world. How quickly can you get there? Well, if you're TikTok, for example, you can get there maybe in 18 months or in 2 years. So the speed of adoption has really changed over time. And now it's super fast compared to 50 years ago. Of course, there is another market in AI that is hidden, that's behind the scene. And you can see this quite quickly if you go online and you look for Scale Nucleus, that's the AI labeling platform from Scale.ai. And that market is the labeling market, right? A lot of AI systems, supervised systems, need labels. So, for example, you're trying to recognize certain skills or entities in text. Those are initial labels provided by human beings. Or you're trying to recognize cars on the road, that is built on data sets where cars are labeled by human beings, right? And this whole market is sometimes called the blue collar work of the future, right? It's a very big market already, and it's a labeling market. It's a pretty boring job where people label stuff, maybe through Amazon Turk or through something else. But that's the engine for at least the supervised learning tasks that we have. Okay, let me quickly check any questions, Kent. I'm not sure if I can unmute you, I think, or ask to unmute. Any questions I should address meanwhile?
Yeah, perfect. So good start so far. There were a couple definition questions that came in on the Q&A section. The first one was, what is machine learning and how does it relate to AI?
Yeah, that's a great question. So typically the chart for that shows AI as a broader bucket and machine learning as a part of that broader bucket. So machine learning is a smaller subset of AI in general. AI in general relates to any attempt to build an intelligent system, like a human being or surpassing the human being. Machine learning typically means that you're building a system that can learn without you going back to program it. So you've built a system like Chemo, a recommender system. And with more data, the system gets better without you changing the initial code, right? So it's a subset where it mostly is symbolic, I think, for the feedback loop, where your product gets better over time with more data.
Perfect. And there was a second kind of definition style question of what is supervised versus unsupervised learning?
Yeah, it's a good question as well. So supervised learning is where you learn from examples with labels, right? So let's say you're trying to predict if something is a cat or something is a dog. If you have a million pictures that are labeled cat and dog, generally by human beings, then you have a supervised learning problem, right? Because it's supervised by the human beings providing the labels. And then it turns out it's a pretty simple modeling task, because with those labels, you can have the model learn the features of those, the pictures that you have, and the labels are already there. So it's just learning the pattern that fits the label that you provided. If it's unsupervised, that means you don't have labels, right? Which is it's a very different kind of problem. Maybe the data set is Wikipedia, and so it's a big chunk of text. Or maybe the data set is a lot of LiDAR and radar data coming in from your autonomous vehicle. But this is all data without labels, which means you have different kind of models you can build. Generally, they're more clustering models or semi-supervised learning models. So I would say supervised is a lot of the old school AI. A lot of the new things are unsupervised, but they're also way more complex to build since you don't have labels.
Great.
Last one,
yeah, I'll let you just build on that as well. There was also a question of reinforcement learning and how it relates to supervised and unsupervised.
Yeah, more complex, but the simple answer is reinforcement learning is let's say goal-directed learning. It's closer to what human beings do, right? So you put a little robot into an environment, can be a software robot or an actual robot, into an environment where there's an end goal. Let's say it's Mario playing a level in Mario, right? So you have your little puppet and it needs to run to the right and reach the end. What it's learning here is what are the right actions to take that are maximizing your final reward. So maybe if you reach the end of the level, your reward is 100. You can code it however you want, of course. And it's learning where to jump and where to duck and all these things to make sure you get to the end. Right, so it's a goal-driven behavior system where you maximize rewards or maximize, you make sure that the right actions are executed to get to the final reward. So different kind of thing. Maybe the best way to think about that is with a game like playing Mario or playing Tetris and maximizing your score. Was that clear enough?
Great. So there were a few other questions, but maybe suggest we keep going, and so we'll come back to them in a bit.
Sure. And we can address them later as well. Okay, let's jump in again. So technology, and some of the questions I'm pretty sure will be answered here as well in the next bit. So what's the technology like? Let's start with something that I think most people will not know, but is extremely interesting, and it got more interesting for me today. So of course, you have a hardware and you have a software side, right? And we discussed a bit of the software side with supervised learning, unsupervised, reinforcement learning. But the hardware side is also a very important chunk. And by now, a lot of companies, of course, use some kind of cloud to do their storage and their compute. And that cloud system, the quality of that and the speed and the amount of compute there is increasing really fast. So what you're seeing here is Google's new TPU cloud pods, right? And TPUs are tensor processing units. So these are chips that are optimized for AI processing tasks. So they're closer to what you would have in your PlayStation 5 than what you would have in a traditional laptop, right? It's parallel computation that can handle lots of different numbers in parallel. So it's a different kind of system. And they're optimizing this. And of course, in the cloud, you can elastically scale this up or scale this down. So that's important to know in the backend that it's becoming more democratized. Anyone with a computer or a smartphone can dial into this, so to say. And it's a little bit like a telephone bill, right? So you use the compute and you pay for the usage, but you don't need to own this. You don't need to have the investment for this, right? So it's changing CapEx to OpEx, as we would say in finance. You don't need an upfront investment. You just pay for the usage. The same is happening here on little devices that sit in the in the end product. So maybe this is the wing of an airplane, or it could be your smartphone, or it could be a little camera that recognizes your face if you walk in. And it's called edge computing, right? And edge computing are tiny microcomputers, credit card sized or smaller, that can handle the initial AI data modeling. So maybe it's, for example, getting the perturbance, how do you say that? If the wings in the plane start moving, right, there is a disturbance, there's a rhythm, and if it's broken, then that rhythm will change. So checking that rhythm against the baseline, what it should be, it's those kind of simple tasks that can be done at the edge. And only when you need more compute power, you might send it to a cloud center. And of course, if you send it to the cloud, it will take time, right? There is a latency there. So a lot of these fast moving things where you need instant feedback on the device that happens instantly is done in edge computing in these kind of devices. There's also a lot of interesting stuff going on in the hood in your smartphone. So if you have a newer smartphone, you will find that these chips are more optimized for AI tasks like computer vision or speaking to it, text to speech, speech to text. So the latest Pixel phone, the latest Google phone is very much optimized for language tasks. So if you see someone speaking to the Google Pixel or translating real time with Google Pixel, it runs way more smoothly than, for example, on the iPhone that I have here. And that's because the chip is optimized for AI tasks. And I think that will happen in a lot of smartphones over the coming years. Suddenly the AI seems to be working better. And part of that is because the hardware is optimized for these specific AI tasks that we're already doing, right? Speaking to Siri, speaking to Alexa, those kind of things. How well does it work? Maybe 50-50, but it's getting much better with these new chips. And then the last ones, and this, maybe you've seen Nvidia GTC, the presentation by Nvidia last week, but I just learned today that we are building a big data center here in Amsterdam, and we're using A100 chips for this. And the super cool thing is that we put them in a bucket of oil, which cools them. So we do liquid cooled, let's say GPUs that we use here in Amsterdam to scale compute power here locally. And it's more sustainable. It reduces the carbon dioxide emissions and the heat loss, etc., because we have them liquid cooled in a particular kind of oil. Okay, let's look at the software side, right? And without going too far, but let me try to give you a quick example of why this AI tooling is so interesting. So most of the AI, the software is generally predicting something, right? So it could be predicting a classification task, like is this a cat or is this something else, A or B? And it could also be predicting something more continuous, like the price of a building. This is Amsterdam, right? So how much would this building be? So those kind of tasks, it's a prediction engine that you're making, and the better the prediction engine, of course, the more valuable that system is. So why is AI special? Because you can also predict in Excel sheets and a lot of other things. Let me explain that with a couple of steps. So let's say we're trying to predict the value of this building here in Amsterdam, right? How are we going to do that? Typically, you look for a couple of dimensions that you think will contribute to the value. So maybe it's the location, maybe it's the amount of square meters, maybe it's the finishing of the building, any dimension that you can come up with. And those dimensions we call features, and those features typically have a weight, right? So maybe the location is very important and something else is a bit less important. So those kind of things that's the traditional modeling system. As a human being, you need to come up with what those features would be, and you would come up with theoretical weights. Of course, you can have experts weighing in on those weights, but it's still a relatively simple model, and most people have only 5 or maybe 10 features in their model. AI is a bit different. You have a lot of input data, like the size, like the location, but maybe way more things. It could handle unlimited amount of input features. And it's able to calculate also the correlations between the features. So maybe the location and the finishing of the building together make a new feature that is very predictive of the price, right? So it's able to not only handle millions of features, but also calculate the interdependencies between the features, and then calculate what are, if you summarize those, what are the really big chunks. And then let's say it predicts that the price is 1.1 million and the actual price is 1 million. It would learn from that feedback and then change the weights based on the actual data, right? So with more data, the system would get better. And what you've automated here is both that feature engineering, where you need to come up with what are the dimensions that I need to model, as well as the feedback loop, right? You don't need to make a new Excel sheet. It's just getting better if you get more data that are used as ground truth. So I think that is the foundation of why this is valuable. It's those kind of things that we automate in this AI pipeline. Of course, this is a very simple thing. So this is all the beginning of the whole AI revolution. There are a lot of ways to make this more complex nowadays, right? So the initial neural net where you predict the value of a house or the classification of a cat or a number or a handwritten digit of those kind of things, that's now changing to a system where we're able to generate content with AI, right? I will not get into the specifics, but for example, here, this is the classification of a cat. And here we did something more difficult where we asked the same AI system, a bit more extensive, could you draw me a cat? So could you create a cat for me? And then it draws this, and it looks a little bit like a cat. It's trained on a lot of different cats. It doesn't look, it's not perfect, but I think we can decipher that it is a cat. But this whole generative stream of models is now the hype. And this is a very simple case, but you can generate text to write fake news or to write articles or to write marketing campaigns. You can generate videos, like deep fakes are generated videos. You can generate audio, so you can make music, all with the same kind of models. So this is a next layer, which is generative AI, which is actually generating stuff for us. And I want to show you an example of a musician who actually generates his entire music collection and then sells the album. So he's successful in making music purely with AI. So this guy is a fantastic speaker. We have a full webinar with him. What he's showing here is, so he loves this kind of music and he's generating samples and samples of music using a language model that he adapted to work on music. For some reason, I don't have the sound. Let me try something else. 1 second. I have it here as well. My sound is not working for some reason. I don't know why that is. Here's why. Okay, sorry guys. Here we go.
There you go. Guitars added on top of the drums. Let's listen to that one. Well, maybe I don't like that, so I do that one again. You have to keep in mind, this is a deep neural network that still runs on my local computer on the MacBook Pro, and it's still very fast. It doesn't run on any special hardware, so there's no GPU required. Okay, interesting. Let's give it another shot. Okay, let's listen to that one.
Okay, so what's the point here? Why am I showing this, right? The point is that the creativity that you would normally need as a musician, where you have to come up with new melodies and all these kind of things, that is automated here, right? So he has a first sample of the music. He doesn't like it, then he clicks, he waits 2 seconds, it runs on his own machine, and he gets a new sample, right? So technically, that whole creative part where you need to come up with something, he has automated building an AI model that he can run on his own laptop. So I think great example of a more generative model. In this case, it generates music, but it could also generate video or text or something else. Let me give you another, now it is working. Let me give you another example of a generative model. This is inside our own software. As you may know, we are trying to build a personalized learning system that can also answer questions from students, right? Again, generative. In this case, it's my wife. She's a general practitioner, so a medical doctor, and she is trying to ask questions that are too difficult for the system to answer. So first question, is RNA more important than DNA? Obviously a bit of a tricky question. And you can see the answer that the system is giving, right? And I think it's relatively decent. Then she tried a more difficult question. What is the difference between whole genome sequencing and next generation sequencing? This is very specific on getting people's DNA through different methods. And again, the answer is quite okay. So both of these examples are generative AI models where the AI is going beyond A or B classification or price prediction. Now we're in the content generation phase. In practice, important note, the slide is a bit complex, and I'll send the slides afterwards so you can read a bit more later. But what does it really mean to make an AI model, right? And in practice, there are predictable steps, right? There's always the same 7 or 8 steps, depending on how you write them down. And 80% of that work is data processing, data collection, data cleaning. So it's the preparation of your actual model training. The model training tends to be relatively simple. There's lots of optimization methods to make sure you get the right model, but making sure you get the right data with the right labels, and that is a lot of work. And the industry is, if you look at those steps, then you can see very specifically where the industry is trying to speed this process up, right? The faster this can go, the faster we can innovate and we can iterate. So all of these steps have software solutions that try to make them go faster. So if you need labels, you can outsource them to Amazon Turk and get a lot of labels, or to Nucleus from Scale, right? If the modeling is difficult for you, you have low code platforms where you can just drag and drop and make models without coding them in Python. So all of these steps we're trying to make faster. If you need compute power, right, and you're waiting for a long time, because I still remember training my first neural networks on my laptop, that it could take 7 or 8 hours or so in the training rounds. Now you would link to a Google TPU, so and it's 10 or 20 minutes, right? So everything here we're trying to speed up. This is an example of a low code platform or no code platform. This is important because it might mean that almost everybody can start to build those models, right? So the vision of those companies making these things is that you don't need to be a data engineer, you don't need to be a software engineer or an ML engineer to do something with AI. You can just drag and drop, right? So you have your data set at the left, and you have your model somewhere in the middle, and at the end, you can specify what you need, and it will optimize that whole thing for you. So the whole pipeline, in that sense, is way easier to make. So this is a way to potentially democratize AI development within companies, right? That's the purpose. Then there's another angle, and after that angle, I'll show you where I think things are going, and then we can jump into a couple of questions. But I think if you say AI nowadays, you also say a bit of geopolitical tensions, right? So it's good to know what's going on there. And the first thing is here on the left, you can see how often the word AI is mentioned in US Congress, right? So, and until a few years ago, technically never, and then suddenly it explodes, right? And what you see here is that most companies, they have a couple of things that they're putting in place. First of all, if you want to buy an AI company, which is important in a specific nation, you may find that you cannot buy it, right? For example, the chip maker in the UK that Nvidia tried to buy, that was blocked, right? Because it's seen as a national interest. It's too important to allow those things to happen. Most countries will also have an AI strategy, right? Which is their view of where they're going with this technology. That means both having the right compute power locally in your country, as well as having the ecosystem for the talent to thrive, right? So this is a game that some countries really see as an existential battle. So China and the US really frame it like that if you win the race, in this case, then you're the country of the future, right? Is that completely true? Maybe not. There are more technologies and more ways to build a country, but it's important to know that this is how it's currently framed on that level. There are also clear things where this rivalry shows up, right? So language models is one of those. I think most people here in the call will know GPT-3. GPT-3 it's become quite famous. It's a big language model that can answer a lot of questions correctly. And you can use it. You can use it through an API, so you can play with it. And a lot of people made simple applications with GPT-3. But GPT-3 was an American model. So quite quickly after that, it had 175 billion parameters, if I'm not wrong. The cost to train GPT-3 was roughly 10 million, right? So you need a lot of money to train a model like that. But quickly after that, Chinese also launched a model called Wudao, which is way bigger than GPT-3. Then Microsoft and Nvidia together built another model. So this whole system where who builds the biggest model that can answer most questions correctly is currently ongoing. And you can see them becoming bigger and bigger and bigger. And it shows a bit of the hardware that you can leverage and the intelligence, of course, of your programmers. The big question is, are we going to get any kind of super intelligent system that has been predicted, I think, at least in every Hollywood movie, but also beyond that? My view, leading an AI startup here in Amsterdam, is that this is not really a realistic thing, at least not in the next 10 or 20 years. Every AI model so far that we see is a very narrow model, right? So it might predict the prices of a house. It might predict whether something is a cat or a dog, or it might predict something more complex, like what is the right answer to the question I just posed. And they're all prediction problems, and they're all narrow, right? The same system you use to answer questions cannot do anything else. And the same system you use to predict cat pictures and cats in cat pictures cannot do anything else. So there's no meta level cognition. There are no emotions. There is no consciousness. And there's no real blending of the models, right? So this, at the moment, for me, it's not a sum function because it doesn't really sum well. These are narrow models that currently are still completely separate. Trends, where are we going? Last slide, and then I have two more little videos to show you how that looks like. But the next few years, I think, are going to be incredibly inspiring and interesting. So what's going to happen next, right? There's a big focus now on data quality. So yes, we can make very big models. They can have hundreds of billions of parameters, but the quality of the data you put in, of course, is one of the key things. So lots of efforts going in that direction. The same thing already mentioned, specialized silicon, like where do you actually run your AI model? And of course, you'll get a lot of specialized companies now moving into specialized silicon, like Halo, like Nvidia, like Google with their TPUs. And they will also show up in your smartphone. There's a whole stream, and I think this is one of the most interesting ones, where companies build virtual twins. So you have maybe a Tesla car on the road, but there's a virtual twin of the Tesla car that is that the company Tesla can look at to understand what's going on. And if you have that virtual digital twin of that particular product, you can also optimize things in that virtual environment before you actually build that thing, right? And that is it's sort of the combination of physics engines and AI, where you have things that appear in real life. You also make a virtual copy of that, and then you learn to predict the right things for that virtual copy, and then you make a better product. So I'll show you a video of that where you can see more advanced virtual twins, but this is a very big thing that everybody is trying to get into, and especially Nvidia has done some amazing work there. Then you have multisensory learning. Like I mentioned before, that everything is still narrow, right? But you can combine those models. So with multisensory learning, you may have inputs from different streams, like a LiDAR, a radar, and something else, maybe a camera, and treat them together into a single model, right? So now you have, it's still not intelligent, but you have multiple data streams that are combined. And the first models are appearing where this is working quite well. And of course, you have this whole push from greater efficiency. As I already mentioned, chips floating in oil, so you don't lose the heat. Few-shot learning, where your model learns with fewer labels than a label for every cat in your database. So it's those kind of things you will see in the near future. Let me give you a couple of examples, and then we'll do some questions. So first, a couple of examples of digital twins where you simulate real life in a virtual environment and then upgrade that digital twin to then, of course, in the end, make a better factory or better car, better helicopter, etc. So this is all virtual. These are physics engines, AI-supported physics engines, where you can see how they're trying to model reality in a virtual space, right? And effects of the wind, effects of boiling, effects of water, all these kind of things they're trying to capture. Climate models. So it's a simple example, but you can see how this would extend to production lines for cars, to predicting things for climate change, to giving software updates to your autonomous vehicle, right? So if you can model something in virtual reality, you can then build better products in the long run. This is not a very important one. It's from the presentation that Nvidia gave a few days ago, and it shows you how this multi-sensory learning is coming to life. So they pitched a new autonomous vehicle. It had a Hyperion 8. It will go to the market here in Europe, in the US in 2024, so pretty soon. And every car has 14 cameras, 9 radars, 3 lidars, and 20 ultrasound devices, right? So it's definitely multi-sensory. It uses all these data streams to then predict, of course, where the car should go, but at the same time build a map of the environment. So it's also a system that builds up the real-time map of the city that you're driving through.
Welcome, Daniel. I see a text from Hubert asking, can you pick me up from the San Jose Civic? Should I take you there?
Yes, please.
Okay, taking you to San Jose Civic.
Start Drive Pilot.
Okay, starting Drive Pilot.
Can you let Hubert know we're on our way?
Sure, I'll send him a text.
Nvidia Drive Map is a multimodal map engine and includes camera, radar, and LiDAR. You can localize to each layer of the map independently, which provides diversity and redundancy for the highest level of safety. Drive Map has 2 map engines, ground truth survey mapping and crowdsourced fleet mapping. By the end of 2024, we expect to map and create a digital twin of all major highways in North America, Western Europe, and Asia.
Okay, so forgive me for the Nvidia pitch here, but the cool thing here is there are a couple of amazing things, right? You can see that multi-sensory learning happening. You can also see the full integration with chatbots, right? And the chatbots with facial recognition, recognizing the person to catch up. The full integration also with mobile, that he receives a text if you're close. And then, of course, that map building from the ground up. So now, of course, we use satellite images to build a map, has a couple of years delay. This is a real-time engine that can be updated every hour or so. Okay, with that said, Kent, I'll stop sharing and over to you to see if there are any more questions from the group.
Yeah, sounds good. Lots of great questions coming in. This has popped up a few times in our previous webinars as well, but how scared should we be in terms of data privacy, surveillance when it comes to AI?
Yeah, so that's the question, of course, we asked you guys in the beginning, right? My feeling is you should be a bit scared. So especially in the last few years, in the beginning, the focus was really on building bigger and bigger things. So getting more and more data from users. If that's the case, and that data is centralized with one company, a Facebook or a Google, my feeling is that's not completely the right model, right? You should have more authority and agency over your own data, which currently you do not have. So I think that's not completely the right model. And there will be lots of regulation coming in, but it's moving slow. So I would definitely be a little bit scared and at least be selective with where you're sharing your data. At the same time, you can see that regulation is now popping up, and you can see also companies moving to more tiny models that need less data to succeed. So there is a big trend where this is becoming a bit better, but it's good to be aware of you share your data with a company that will use it to increase your engagement or do something that is beneficial for them.
Makes sense. And you're mentioning some of the legislation. There was also a question of use cases from military or governments, but maybe just to expand that, based on your experience, how are governments thinking about this in general, and any additional things you can say on that front?
Yeah, so I have some experience there. I consulted for the G20, so I had conversations with ministers on this. I also spent some time in other countries looking at what's currently happening. My feeling, to be honest, the general sense is that governments are moving very slow, right? So from a government perspective, if you're a minister, for example, of course, you're elected and you're not necessarily an AI engineer or a cloud engineer. So you will not know everything and you'll need time to catch up. And regulation, of course, has a timeline that can take years, right? Where entrepreneurs can take minutes or hours to build something new. So my feeling is that legislation always comes a couple of years later than it should come, and the real speed is in the decentralized innovation that entrepreneurs mostly do. So yes, it's coming, and yes, it's good that it's coming, and the EU is leading, I think, in that legislation, but it's still almost always outdated, not completely fitting the market, and most of the innovation will come from young companies. That's my view on that.
Great. There's also a couple of questions of conversation or NLP sides, how it relates to chatbots, even on the hardware side with robotics, like with Sophia. Not sure if you're familiar with that. Any developments you're seeing in that space?
Yeah, so it's a couple of questions in one, right? But so chatbots, let's say you have different levels of chatbots. You have a very simple chatbot, which is hard-coded. Do you want to have your invoice? Yes, I want my invoice, and you get your invoice. And the yes is just a button. That's the first layer. Now, the second layer is where the chatbot starts to recognize intents. So you have a text field, and you can speak or you can write, and it will understand your intent. And that intent is a classification algorithm, right? So maybe you want your invoice, or maybe you want to see your current bill, or maybe you want to do that. So it's going to recognize it's one of the other, and you're as a user, you're searching for one or the other. The problem there is that humans in reality are very complex and can have millions of different intents, right? It can be a joke, it can be a question for your invoice, it can be a question about the weather. So in our experience, we tried to make one that was very complex with a couple of hundred intents, but the more intents you add to the chatbot, the dumber your chatbot will appear, because it will confuse your intents more often. So the complexity is in, it's easy to make a chatbot that does one thing right, giving you your invoice. That's easy. It's very difficult to make a chatbot that does everything right? Because then suddenly it needs to have a really, really smart model with that classification. So I'm also still a bit critical for things like Siri, and because it works a little bit, but it doesn't really provide a lot of value. And currently the best things are all very narrow, and it does one thing really well, and only that. When it comes to Sophia, right? Sophia, of course, is a robot with a language model inside. And I think the whole appearance of having a human-like character with some moving facial muscles, and that adds to the magic, right? And of course, you're also seeing digital Sophias. So Sophia is an actual robot, but you can also have a software robot, an avatar that starts to speak to you. And there's a lot of companies working on that you feel you're talking to an AI, and it actually looks like a robot or like a person. And also there, it's extremely intriguing. We had a couple of different chatbots in the past. Even if you give it a male or a female voice, it's very important. If you in my view, you should have both, right? If you give it a female voice, people have an opinion. If you give it a male voice, people have an opinion, just based on gender and how it sounds and how it feels like for people. So also getting that right is a big thing. So I don't have an example, sadly, of what I think is best practice, but I think it would be close to what Nvidia showed in the car. So it's not a human being. It doesn't look like a human being. It doesn't have a gender. It's a little robot-like character that, is not threatening, looks very pleasant. I think that's where most companies will go, because it's the least threatening avatar that you can have.
Sounds good. We've been talking a lot about the technical side of AI, and there's a question here of what role does the design side of AI, what role does design play in AI?
Yeah, I love that question, and I already touched upon it briefly now with the chatbot. in my view, quite a lot, right? Because if you're willing to trust the system, the design of that system matters a lot. Like certain products just feel way better, or feel way more unbiased, or feel way more pleasant. So we'll have a lady that is working at Microsoft focused on chatbots and the next generation chatbots from the design angle. I think we'll have a webinar with her in a couple of weeks. So she can say more, but I can only confirm the lessons that we learned. Gender is super important. The way you make it look like is very important. First, we had just a circle you could talk to. Didn't mean much. Then we had a pixelated human. Everybody hated it. Then we switched on your webcam and you could sort of see yourself with a lot of AI models. Everybody hated it because it invaded privacy. And in the end, we stuck with a little circle, which at least is anonymous and non-threatening. So design side is huge, and we'll have a session on it in a few weeks.
Great. And then just looking forward, there's a question of who really are the leading companies or players in developing these trends?
So of course it's an opinion, right? But I think Nvidia is very much leading. Nvidia is doing both the hardware development, like the A100 chips that I showed, as well as the whole software stack you put on top of that, like the Omniverse, like the digital twin software that I showed you. All of that is from Nvidia. So my feeling is they're moving really fast on all of these trends. Then, of course, you have the Googles that have specialized clouds, TPUs, and pixel chips. You have a lot of narrow players like Halo who focus on AI hardware, but then edge hardware, right? For in the wing of a plane, these kind of things. And you have a lot of software players like us that are trying to build a better education or healthcare kind of tooling with AI. So the beauty of it, it's very, very decentralized. Everybody is trying to make something better. But the big players that I look for, DeepMind, Nvidia, and Google, I think are the top three that come to mind.
Excellent. And there's two other questions. If okay, I'm actually going to answer the next one, and I'll finish off with one that I think will be very near and dear to your heart. There's a question of the webinars that you're mentioning. If individuals here can attend, if okay, I can answer that one saying absolutely yes. They are free for attending. And anyone interested in any of our other webinars coming up, they're on our Eventbrite page, or actually in the Chemo app for any of you looking to download. Just to give you a taste of that, we have on April 7th, so in a couple of days, designing a people-centered metaverse with Nvidia, and on April 12th, next week, generative AI with IBM as well. So a couple of great webinars there. And then just to finish off, friends, I'm guessing this one is very near and dear to your heart. The question was really around, is learning AI and machine learning really only worth it if you can build something big and significant? Or do you see this really as a skill that everyone should have at least a general understanding about going forward?
Yeah, that is a question very dear to my heart. So I would always promote learning about AI because it's central to all the industries that you're going to work in, right? So as shown on slide 1, it will be central in almost everything that you do, whether you go shopping in the supermarket, which will probably be in some ways completely automated at some point, or you're going to jump into a car, which is then an autonomous vehicle, maybe somewhere in the next 10 years. So all of these areas will be impacted. And my view is that if you're going to build something that's fantastic, but if you want to understand the world that you're living in, you should study a bit of AI, right? Purely for the sake of understanding what's happening around you, you should probably do it.
Perfect. I think it's a good place to wrap up. Any last words, Rens, before we finish?
I think those are my last words. Thanks for attending, guys. Appreciate it. Lots of fun. And thanks for all the questions. And I hope to see you soon in another webinar.